Let's talk about the stack first. And this is rooted in the idea of the way we like to define AI engineering. That is, as the industry relevant set of skills that data science and engineering teams need to successfully build, deploy, operate, and improve large language model applications in production. Okay. There's a well known LLM app stack. And I think this is sort of the leading representation of the way we can think about building these in the industry. This was put together by A16Z in June 2023, updated in May 2024. And it's based in this idea of the sort of core idea of prompt engineering that came out of the GPT-3 paper in 2020. And that is this idea of in-context learning. It's all about putting the right stuff into the context window. And leveraging this design pattern, whether it's through retrieval, augmented generation, or through agents, is fundamental to how we think about building these applications today. And while you can sort of look across this stack and focus on embeddings and retrieval and how to do inference and how to do monitoring and how to do logging and how to put on guardrails and how to do all this different stuff, we actually don't need to focus on very much of that to get started. This is the stack visualized, and you can kind of see that in the center we have some way to do this orchestration. We're going to have some sort of way to host our application. And importantly, we're going to have some sort of API on the back end, whether it's an open or closed API, doesn't really matter. We need to be able to hit an endpoint that gives us a response back from an LLM. Now, all of this stuff up top here, we don't really need to worry about today. This is more associated with building your first RAG application, or if you want to connect to external APIs, that's going to be where you sort of are able to hit, things agentically. You're able to sort of call tools and functions. You can talk about caching and LLM ops and validation and guardrails, but we actually don't need to talk about almost any of that to build our very first application. And we actually don't need to focus on many of these arrows either. We need to focus on just a couple, the blue and the red. And we need to focus on just a few of these boxes. We need to focus on hosting the app, orchestrating any application logic, and connecting things up so that we can hit an API and we can serve back the response to our user. You imagine the user sits here, asks a question. That question goes into the orchestration. That heads back to the LLM. The response back on the red lines comes back into the app and is provided to the user as an output. This is the simplest possible LLM application that we want to consider. And we've picked a couple of tools that we're going to go through today with you. One is Vercel. This is the best app hosting tool that we believe exists today. The orchestration is quite simple. We are Python developers. We're going to leverage the OpenAI Python software development kit. This is a really great Python library, perfect little starter kit, especially if you're going to leverage an OpenAI API endpoint of one of their models, which of course we are, and we're going to pick one of the most recent GPT 4.1 mini, although we'll show you how to put a few options in there if you'd like. Now, importantly, this piece right here, hosting the app, this is a part where a lot of people often get confused, and historically myself included here. We want to kind of think about the back end and the front end existing almost at this intersection. And we can kind of think of this kind of back end as often being, whether we can see it explicitly or not, a back end that is kind of using a fast API server. Now, historically, you might have used Django or Flask or some other types of web app frameworks, but Fast API has really emerged as the leader here. And so you'll find it underlying a lot of the different back-end app hosting that you might do. We will go ahead and build this back-end today for you so that you can simply worry about hosting it. This is an important piece, especially if you're trying to build production grade applications. Now, on the other side of app hosting, this is sort of where the user asks the query and we get a response in output. This is where vibe coding comes in. This is where we can leverage some of these cool vibe tools to quickly build a front end. We don't need a sort of static front end anymore. We can kind of go with the flow of whatever we think our users are going to like. We can kind of leverage some of the more fun terminology, make it a little more menacing, make it a little more dark mode, make it a little more fun. And we can really embrace the vibes here on the front end. And it really makes front end development much more approachable. So we highly recommend doing this. And this is our recommendation and one of the pieces of the challenge we want you to all go through. And this is it. This is all we need to do to really get started building, shipping, and sharing our first LLM application. This is an important thing to understand. Many of you probably already know this, but this is a great time to start learning this as a new AI engineer, as a new aspiring AI engineer even. This was something that was introduced in 2023 and really became an industry standard. It's been updated as of 2025, and specifically this idea of a chat style model. This is sort of, instead of just putting in text and getting out text in, text out, what we're doing is we're sort of allowing the LLM to kind of have a conversation. Again, it's that design pattern of in context learning. What are the things that we're putting in context as we kind of have a conversation? And the difference between chats and text in, text out is that we actually put in a list of messages. And then each time we get an output from the LLM, we get another message appended to the list of messages. And you can kind of see here that we have a few different roles in these examples that we have shown on screen. The role now that's important to understand is the developer role. The developer role has replaced this idea of the system prompt. And it's basically like, it's up to you as the developer working behind where the user sees to describe how you want the LLM to behave, how you want it to appear, what kind of role you want it to take, the vibes you want it to give. For instance, the developer role might just say, talk like a pirate. And the user role is just your user interacting with your application. Or it could be, could actually be you pretending to be a user on the front end. And this idea of developer role and user role, on the one hand, we're providing instructions, we're kind of setting higher level objectives. The user is just you testing this thing, or it's your actual user. Like every time a user hits your app, you'll see the user messages on the back end. And finally, there's this idea of the assistant role. And the assistant role is anytime the AI responds to a user inquiry, right? And additionally, importantly, you can sort of act like the AI responding, provide sort of a user input and then an assistant input. And that's kind of like a one-shot example. For instance, here's the sort of question answer one-shot example. Who won the World Series? The Los Angeles Dodgers won the World Series. So you're sort of having a conversation, and you're sort of mimicking a real conversation with your one-shot, two-shot, few-shot examples. And, this is from the most recent version of the OpenAI docs here. The developer role are instructions provided by the app developer. That's you. And importantly, these will be prioritized ahead of user messages. So it sort of has a bigger weight. Whatever you write in the developer role, that's going to impact everything about your application. Whereas the user role is just instructions provided or questions asked by the end user. And finally, the assistant role is messages generated by the model or examples that you provide.
A Colab notebook that's going to show us how we can use OpenAI as a developer. What does that mean? Just how do we use the OpenAI, Python SDK? We're going to leverage this when we build our application. That's part of the challenge. First of all, of course, we need our OpenAI API key. We're going to use this as an environment variable, and then we're going to use this Python standard library getPass, so that you don't have to keep your password, your OpenAI key in plain text in the notebook. And then we are going to look at some prompts. As Greg has already mentioned, there's this idea of developer, assistant, and user prompt. The basic idea here is that we are going to use these three prompts to, achieve different tasks, as Greg just mentioned. And what I'm actually going to do is I'm going to share my my cursor window with you guys so that you can see this as it exists in the code in cursor. So we have it here, and you'll notice that we have a client. The client is basically, what it seems like. It's just a client. It is what lets us hit OpenAI, right? And you'll notice that we have nothing in here. But if we wanted to, we could add a new base URL. And this base URL is where we would do things like change this to work with another provider, right? So this is the flexibility that the OpenAI client offers us. You'll notice that we have this prompt, and then we have this client, which is what we just set up. We have a chat endpoint, a completions endpoint, then create to create a request. We have our model, which is GPT 4.1 Nano in this case. And then we have some messages. You'll notice that the messages are always in this object form. This object form basically allows us to specify the role of the message, as we see above here. We get a response, and we get this response in this big blob, right? Filled with information, which is awesome, but we don't care about for the purposes of our application just yet. So what we're going to do is we're going to create some helper functions that just pretty prints the response without all of that other stuff. And this is just going to make it so that we can see our responses directly. We can test the helper function by, using the same prompt, creating a user prompt with that prompt, and then using get response, and then pretty printing our ChatGPT response, and it will give us this markdown formatted, blob instead of the thing that we saw above, which is containing too much information. Let's extend this a little bit and use our developer message, right? So instead of having just a user prompt, we're going to also have a developer prompt. Now, what the developer prompt does very straightforwardly is it's like a place you can add instructions and things like this. So in this case, we have you are irate and extremely hungry, and then we have some question: do you prefer ice or cubed ice? You'll notice that the model's response is, right here. Are you kidding me? I don't have time to mess around. I'm absolutely starving, et cetera, et cetera. All this is showing us is that while the developer prompt is here and clearly influencing the response, it is not actually, we're not addressing it directly in the response. So let's do the same thing, but instead of the angry developer prompt, let's use a joyful developer prompt. And we see, I think crushed ice is so fun and refreshing because it cools drinks quickly and adds a nice texture. There you go. Okay. Then we have this idea of few shot prompting, right? So this is going to be important as you move through things in your prompting, experimentation. What we're going to show is just this simple example, right? So we can ask, please use the word stimple and fall bean in a sentence, and then we get some like hallucination, right? The model just kind of makes something up because it has no idea what these words mean. So what we can do is, using the assistant prompt, we can actually define or help define what these words mean. So we have the user prompt, which defines what stimple means, and then we have an example sentence. And then we can ask for a new sentence that uses the definition of fall bean. And then we get a correct sentence. Stimple fall bean crafted by the craftsman ensures smooth rotation, reliable fasting for all our machinery, right? The idea here being that we have the actual ability to show examples, right, through those user and assistant prompts. Then, of course, we have our favorite chain of thought. Now, you'll notice, I asked this question, right? Billy wants to get home from San Fran before 7 p.m. Eastern Daylight Time. It's currently 1 p.m. local time. Billy can either fly and then take a bus, which is going to take 5 hours, or teleport in a bus, which is going to take 1 hour. Does it matter which option Billy selects, right? And we get the response, yes, it does matter, right? But it it still says you could take the whole bus time, right? Which is not true, because 1 p.m. local time in San Fran is too late. So our option would get us in after our event started. The idea is that the model, you'll notice it does a bit of thinking step by step, right? Like, but it doesn't really go full send. So what we can do is that with the same prompt, we can add, let's think step by step, right? And this kind of thought process, by the way, is the same thing that powers models like O4 and O3, right? All of these reasoning models. This is what helps power them. This idea of chain of thought. Now, when we add this step by step, you can see we analyze the current situation, we look at both options, we calculate arrival times, and then it does matter because the flying plus bus option will get him after the deadline. So by encouraging the model to think through the problem step by step, we can see that we actually get a better response, right? And this is really important when we're making applications as we go forward. All right, there you go. With that, I'm going to pass you guys back to Greg, who will help us get to our next demo. Oh, yeah. Okay, so here we go. We're going to start in the browser, then we're going to move over to some code. So what are we looking at? Well, this is GitHub. This is where we're going to start. So it's the AI Engineer Challenge. It's going to be straightforward. The idea is the first thing we need to do is we need to fork this repository. And the way we're going to fork this repository is by clicking the little fork button here, right? And then we can create this AI engineering challenge, and then we can create the fork. So this is the first step of what we're going to do, right? And you might ask, why are we going to fork this repository instead of just cloning it? Well, because we want to commit changes to it, right? And you don't have access to do that on the main. So first we'll fork. Once we fork it, we're going to go ahead and we're going to grab the git clone option. And we're going to use SSH because we just always use SSH. If you follow our on-ramp, you're going to wind up with SSH set up, right? So now we have that in our clipboard. We're going to keep that in mind. And what we're going to do before we move to showing you guys some of the code is we're going to look at what this will result in. So what is this going to do at the end of the day, right? And what you're going to wind up with is something that it may not look anything like this, right? But something in function that's similar to this, where we have the ability to provide an API key and then ask questions and get responses, right? So I can say things like, is vibe coding the future? And then our LLM is going to process this message, and then it's going to go through and it's going to give us a awesome little summary, right? This is the idea, though. We're just wrapping ChatGPT in a front end that makes us happy, and we're pushing it to this deployed link, and everybody can use this. You will have to provide your own API key, but everyone can use this by visiting the link we put in the chat. And this is what you're going to wind up with at the end of this challenge, right? So I'm going to show you one more thing, which is how this looks in Vercel. So you'll notice that we have this project called the AI Engineer Challenge. We've got this production deployment, and we have these domains that we have that express where our app lives. We have some firewall, we have some observability, and we have what we're actually looking at, the actual code that was used to generate this. Now, all of this is handled through Vercel for us. And you'll notice when we go through the rest of the demo, to do this in reality is very straightforward, right? But you can see we have this branch, and in this branch, we have everything that we've got. We've got our build logs. This is how we built the app. We have our deployment summary, right? Which is our functions, including our API. It's all done through Vercel, right? This is what we're going to wind up with. Okay, so now that we've seen what we're going to wind up with, we've seen forking the repository, which again, we just did by clicking the fork button. And then we went to code to grab our SSH address. we are now good to go into our actual VS Code window, and we are going to look at this in the code. Okay, so of course, I've cheated a little bit, right? I've already cloned this, but the idea would be we would go to our terminal and we would use our git clone with that new SSH address we just got, and then we would hit enter and we would have a good time. But I've already done that, so we're not going to go through it now. So we have a couple things in the README that we want to make sure we've done. The first is making sure we've set up our interactive dev environment. This is needed for our Git to work, right? This is needed for us to have a cursor and for us to have UV, something we're going to use. And then we have our first step, which is going to be accessing GPT 4.1 mini like a developer, which is a notebook you just saw. If you wanted to run that locally, you can use UV to run it locally. We do, though, also provide, of course, a Colab link if you prefer Colab. The next step you've already done, which is forking and cloning this repository. The next step is setting up for vibe coding success. So this is where we're going to cheat just a little bit. Instead of going directly to vibe code world, right? We're going to take a pit stop and we're going to do some pre-work, right? We're going to do a little bit of preamble. And the reason we're going to do this is because we want to find success with our vibe code, right? We don't want to just, even in the most simple of cases, we want to think critically about the thing we're trying to produce. So we need to do a couple things. First thing we need to do is we need to make sure that our agent, when we use it, is going to have access to documentation, and that documentation is going to be, from the tool's website. Okay, then what we're going to do is we're going to look at this by using Command-Shift-P or Control-Shift-P if you're on Windows. We're going to type in doc, or we're going to type in custom doc, right? And we can go to the add new custom docs. And then let's say we just want to, take some random documentation for React, right? In this case, we don't care too much about this, but we'll just do it for the purposes of an example, right? We're going to copy and paste this into the add docs prompt. We're going to see React, prefix React, entry point React, learn. Then we're going to hit confirm. We have to choose a new name. Let's call it React 2, right? So just to keep things real above board. And then we'll see that we have the two different options here. React 2. We've already indexed Next.js. We've just started indexing our Vercel docs. And we need to do this so that our LLM has access to the latest documentation, right? If we don't do this, we wind up in a situation where, we might hallucinate or use old versions, et cetera, et cetera. So this is the first thing we do to find success with our vibe coding. The second thing we do is in this .cursor/rules, we build some rules. Now you'll notice that we have 3 sets of rules: front end rule, general rule, and README rule. Okay, so our front end rule is what's going to help us understand how to set this up as the front end. We've set some rule types for this, right? The rule type is going to be always. So it's attached to every chat and command K request. What does this mean? Every time we use the chat window, we're going to use this rule. Now you can set more granular rules, right? Like we can say agent requested, and we can see useful for when you need to design a front end, right? And now when we're designing a front end with our agent, it's going to be able to see that it should use this rule, and therefore it should use it, right? Our README rule, we have a different rule type, which is auto attach, which is every time we're working with a .md file, right? And, Greg and I like keeping things light, keeping things fun. And so the rules reflect it should be a dope README, right? It shouldn't just be boring, plain README, and it should be fun, but still be technically accurate, right? A balance that's very important to us. The idea, though, is that these rules, right, keep us on track. So what other rules do we have? Well, we have my favorite rules, which is this general rules. You should always commit your changes whenever you update code. Always write documented, well-documented code. Only work on one feature at a time, and explain your decisions thoroughly to the user, right? These are just simple rules that are always going to be leveraged in the always category here, right? And they help the vibe coding experience, even though it's a little bit more toward AI assisted development, right? It helps it be on rails a bit, helps it really, be more likely to be successful. Okay, now we've set up for vibe code success. Now we're going to vibe code. We're going to go ahead and use Command L or Control L if you're on Windows, and we're going to open up our agent. And you'll notice that, of course, I've already done this because this is a cooking show, so the magic's already happened, right? But the idea is that we will simply ask Cursor to create a front end, and then we will run the front end. And then if we run into any errors, we will copy and paste them back into the Cursor chat window and ask Cursor to fix them. That's it. That's what we're going to do. So that whole matrix style, terminal style UI, this was accomplished in the following prompts. I said, using the front end rule, please create a front end for the application that looks like a matrix style terminal. We see the agent just full sending, looking at our files, right? Creating some package.json, doing some stuff with TypeScript. Don't know, don't care. Making a TS config. This seems like it's necessary. Don't know, don't care. Creating a layout for next.js. I have no idea what any of this code does, but you best believe that I clicked accept on it, right? And did the same thing. And then it produced a README because we asked it to, and that's nice of it. It also wants us to commit our changes, which is important. And so we do. And then the app should work with the Fast API server backend, but it looks cool as hell because it wasn't working with the backend, right? I didn't even provide an error. I just said, it should work with it. And so the agent changed whatever it needed to change, and now it does work with the backend, right? That's it. That's that whole step, right? We just ask Claude to make the front end in a style we want. You'll notice that we're in agent mode. We're in auto mode. We are full send. We are not. It's not asking anything. We're not reviewing. We're just mashing accept, right? That's the vibe code. That's how we do it. Now, there's one more piece that you're probably like, well, I'm missing something, Chris, right? I'm missing, what is the app actually doing? And this is the backend code that we've provided for you. So we've provided this template for you. It's got more comments than it needs to, but the idea is that this should be very helpful in understanding what is actually required on the API side. And you'll see it's not much, right? We have some imports, of course, Fast API, Pydantic. We have our OpenAI import, and then we create an app and we title it, right? OpenAI Chat API. Perfect. We do this CORS middleware. We need to do this because we have this front end, back end situation. If we don't do this, then our app will complain. And then we build our data model. This data model is for Pydantic, and it helps everything go smoothly between the front and back end. And then you'll notice that we have our app.post API chat, right? This is the endpoint that we'll hit. It's going to be a streaming endpoint, right? As you saw in the demonstration, we're streaming the tokens out because we don't want to wait. We don't want that bad UX, right? And what it's going to do is it's going to take that data model as a request. It's going to initialize a client with an API key, and then it's going to use this generate function and then stream the response through Fast API's streaming response endpoint, right? We also have a health endpoint, so we can check the health, and then we are running it with Uvicorn, right? Uvicorn is going to be the thing that runs it. It more technically in Vercel, it's actually going to use this serverless pattern, but we will do this for local development so that we can run this thing locally, right? And that's it. It's just a streaming API endpoint for Fast API. That's our app, right? So we've got our app. We've got our front end, right? We've got what we need. The only thing left to do now is to deploy it with Vercel. And so what we do is we simply, make sure we've signed into Vercel in our browser. We ensure we have NPM, right? which is likely to have been done while you were vibe coding. If it's not, though, ask Cursor, right? If you need, hey Cursor, right? Command L in the browser. Command L. Start a new chat. How do I install npm? Boom, right? This is what we want to get used to. Staying in the IDE, leveraging it as much as possible to help us do our jobs. Finally, we deploy it with Vercel. We just type the word Vercel, and then it works, right? And then it appears on the website. That's it. That's all you do, right? There's like some instructions the first time you do this, but after you do it the first time, right, we'll go to the terminal, I'll open it up, and we'll just write Vercel. And that's it. And now our app is being rebuilt on that endpoint that you guys have access to, and the new version will be available. There's no changes, so it's going to be the same. But that's it, right? This is why we chose Vercel. There is no thinking. There is no worrying. It just works, right? It just deploys. And of course, you can run it locally. You might ask, well, how do we run it locally? Which is a great question. Well, because of our rules, right? We have a README, which tells us, and by the way, look how cool that README looks. Many emojis, right? Fun, but also accurate, right? And it tells us exactly how to run that front end. And how do we run the back end? You best believe there's a README. I wrote this one, so it doesn't look as cool, but it has exactly what you need to run the back end, right? And that's if you want to do some local development before you push into Vercel. And this is the idea, right? The challenge isn't to understand how to produce a production grade application, though you'll wind up with that, right? The challenge is, how do we leverage this incredible tool called Cursor, or whatever version you're using, to make us able to produce these POCs quickly, effectively, and okay, I'm biased. In a way, it looked cool. I liked how the Matrix one looked. Okay, and that's it. We're gonna pass you back to Greg. Hopefully, this has been helpful to have the step-by-step walkthrough. Right, a basic idea again. We built the API. Once we have the API set up and working, all we have to do is say, "Hey, whip up a front end for me using whatever framework," and Cursor just does that. And then we deploy it using Vercel by typing Vercel into our command line. That is the idea. Before I pass you guys back to Greg, got to ask you to ring the bell. We're live every Wednesday at the same time. We love to see you in the next one. And with that, we'll head back to Dr. Greg to close this out.